Bismillahirrahmanirrahim. This is me, Miss Aisha Manzoor, and you all are watching my channel Chemistry Solutions. So here are some of the queries from the students. So we are going to answer those questions from the Cambridge exams 9701 Chemistry paper 1. So here this one is a question from the October-November 2023 variant 1-2. So the question 11. Am I audible?
Yes, ma'am.
Okay. Nitric acid is made industrially by the oxidation of ammonia. The overall equation for the process is shown. Equation 1, NH3 plus 2O2, nitric acid and H2O. The process happens in 3 stages. The equations and enthalpy changes for these stages are given. So here are some of the reactions given. First stage with 4 ammonia, it is going to give us 4 nitric acid, but here in the question which is given to us, 1 mole of ammonia is going to produce 1 mole of nitric acid. So we have to move on accordingly. With 1 mole of ammonia, 1 mole of nitric acid is produced. So what we will do, so this is the enthalpy change which is produced by the 4 moles. So if we are going to talk about the enthalpy change, number of moles here and enthalpy change here. So we required 1 mole. Okay, 1 mole of ammonia is produced 1 mole of nitric acid. So if 4 moles produce minus 904 enthalpy change, so 1 mole, how many amount of 1 mole will be there? So you people will get कि आपके पास 1 mole में कितना आंसर आएगा. It will be, if you will divide by 4 the value, you will get the value. What is the answer? Quickly take the calculator, beta.
Yes, ma'am.
Next part we will do with this stage 1. Stage 1 we have got the answer. For the stage 2, if 2 moles are there, so minus 114 enthalpy change is shown. For 1 mole, how many enthalpy change will be there? So it will be minus 114 divided by 2, because we are making it 1 mole, na? So if we are going to make it 1 mole, we have to divide it by 2. So in the third, we will have this one, our second one. In the third one, we will have 4 moles produced, minus 348 kilojoule per mole, whereas how many energy will produce, enthalpy change will be there in 1 mole. So what will be the answer, beta? One by one answer it. I couldn't take the calculator.
Okay.
So what is the answer for the 904 divided by 4?
Minus 87.
Minus 87 for it. Okay. What is the answer for?
No, ma'am, minus 226 for 907 and minus 87 for the third one.
Minus 87 for the third one, and for the first one the answer is, yes?
Minus 226.
Minus 226. And what will be the answer with the second one?
Minus 57.
Minus 57. So if 1 mole we are using in all 3 stages, 1 moles are involved, then for 1 moles we have got this, we have to add up all of these values. We have got these values, minus 57, minus 226 and minus 87. So in the next step, what we will do, we will add up all of these values. Like you have to add minus 226, minus 87, minus 57. What is the answer for it?
370 minus 370.
Okay, minus 370 kilojoule per mole will be our answer. So here is the question, that is question B. Which one is the correct option? So your next, is it clear?
Yes, ma'am.
Because in the question, basically you have to read the question carefully. In the question, Nitric acid is made industrially by the oxidation of ammonia. So overall process were there. So we have to calculate it for the 1 mole of ammonia to make 1 mole of nitric acid. So this was a question, and the next question was it. Okay. Question number 12. Chlorine reacts with sodium bromide. Okay. Which words correctly describe this reaction? Okay. Now move on towards the chlorine will have the oxidation state 0. Minus
0.
1 will
Yeah.
be bromidine, 0 with bromine, minus 1 with chlorine. So if you will see, and we will have a look on the from 0 to minus 1, it is going to be reduced. From minus 1 to 0, it's going to be oxidized. So for the reduction and oxidation process, we will say this one is zero-redox reaction is correct. Yes, it is displacement
Yeah.
reaction because chlorine displaced bromide ion from along with the sodium. So this one is the displacement reaction as well. So it is not going to show us disproportionation. Why? Because chlorine is not oxidized and reduced simultaneously in this reaction in the product side. So this one is not correct. Our correct answer is 1 and 2 only. Okay, is this clear?
Oh. Yes, ma'am.
Yes, this question you have asked. You send me these queries. Okay. NaOH is added to ammonium chloride. The mixture is warmed. The gas that is produced turns damp red litmus paper blue. Which row is correct? So actually, always it happens whenever we talk about the alkali and reaction of alkali with the ammonium chloride or with the any ammonium salt, ammonia gas will be formed or liberated or evolved. So sodium hydroxide basically reacts ammonium ions. Basically we will see the ionic equation. Hydroxide ions reacts with the ammonium ions to form ammonia and water molecule. So whenever we talk about the ammonia, so it is the proton donor. So behavior of the ammonium ion in ammonium chloride. Ammonium ion in the ammonium chloride, it is donating the proton. So that's why proton donor is acid. Proton donor is called an acid. So if proton donor is acid, then we will say Bronsted-Lowry acid. So it means that in these two options can be, not these two will be the part of this answer. Okay, first option A, B, maybe B. Let me check the rest of the behavior. Behavior of the water present on the litmus paper. So always we use the damp red litmus paper will be used for the test of ammonia gas. Why? Question is the gas that produced turns damp red litmus paper blue. Which row is correct? Behavior of the water present on the litmus paper. Actually, when ammonia gas react with the water present on the litmus paper, okay, if it's litmus paper, water is present on it, okay. So here at the end result, this ammonia reacts with water to form ammonium ion and hydroxide ions. So these hydroxide ions turns red litmus paper blue. Why? Because it's an alkaline in nature. So this will be the reaction which will be taken place at the surface of the litmus paper when ammonia gas reacts with water to produce hydroxide ions. So what's going on here? What water has done? Because we have to tell the nature behavior of the water present on the litmus paper. So basically H2O is proton donor, and if water is proton donor, then in that case it acts as an acid. So this reaction is basically the part of it, the Bronsted-Lowry acid. So this is the answer of the Bronsted-Lowry acid. So this is the correct option. Right? I hope so.
Yes.
This question is clear to you. Let me see your next query. Okay, this was a question. How many geometrical cis trans isomers are there of hex 2,4-diene? A, none. Hex 2,4, none of 2,4-diene does not show geometrical isomers, or 2, or 3, or 4. So these are the options. First of all, I'm going to draw the structure of hex 2,4-diene. So in order to get the good understanding, first of all, we have to draw the structure of 2,4 hex 2,4-diene. Okay. Now 2,4-diene, if this one is our carbon 1, this one is 2, double bond is here, then again 3, double bond 4, 5 and 6. Okay, now we will complete its structure. This one is the second carbon atom, this one is third one, fourth, fifth, okay, and 6. So this one is the structure of hex. Hex means 6 carbon atoms are there, 1, 2, 3, 4, 5 and 6. 2,4-dienes means at the position of 2 carbon bond is present and at the position of 4 double bond is present. So the structure is, this structure is clear to you?
Yes, ma'am.
Okay, now look at this structure and we will see here, look at the position of the hydrogen atoms. So what we will say, this one is the cis and
Yes,
here
ma'am.
this one is the
cis.
trans. So come towards this point, this shows cis and trans. So geometrical isomer, this shows cis and trans. So how many geometrical isomers are there? So we will make its geometrical isomers. I will make the skeletal, if you can understand by the skeletal formula, I will give you the understanding of it. This one is a cis trans. So it can be like this. So double bond is here, double bond is here. Okay, it can be here, it can be here. Okay, if I will draw, let me show you the position of hydrogen. If hydrogen is here, hydrogen is present here. Here is hydrogen and here is hydrogen. So both of these structures will be cis and cis. Did you understand?
Yes, ma'am.
Now come towards the next one. Here is the hydrogen is here, double bond is here. Then hydrogen is here. Then hydrogen here. And then hydrogen is here. So if double bond is here and double bond is here, what we will see it? This one is the trans and trans. Okay. Another sum up way, if I will show you with it, the more precise way, the shortened hand way, how will you show these? There are 3 isomers which it will form. If it can form like this, look at here. If we will say this one is the double bond are here, double bond are here, and this. If this one is trans and trans, okay. And another way, remember one thing, that cis trans and trans cis will remain same. Cis trans and trans cis will remain same. So it will be the same isomer. One isomer is this, another one isomer is trans, and the next one is the cis. We can form cis and then cis and then down. This can cis and cis. So in the if we will summarize it, then it will form 3 types of isomers: cis trans, cis and trans. Is it clear?
Yes.
Okay, good. Now we should move on. Let me check the questions which you asked. Okay. This was your question. Oxygen has 3 stable isotopes, oxygen 16, 17 and 18. All 3 isotopes are present in a sample of oxygen gas which was analyzed during a mass spectrometer. How many peaks associated with O2 plus ion would be expected? Okay. Now we will check the peaks. If we will check the molecular mass or atomic mass of the atoms and O2, this one is the O2. The molecular mass can be 16, 16, 32. Okay. It can be 16 and 17. That will be the 34. It can be 17, 16, 17. It can be 17 plus 17, but both oxygen atoms will have same 34. So we will exempt this one because both is 17. No. 16 plus 17, 33. Calculation gadbad. 16 plus 17, 33. 17 plus 17, 34. It can be 16 plus 18, 30, 34. So we can take one value of them. So we will take this one. Another one, oxygen 17 and oxygen 18. The possibility is these three. We have these three actually 16, 17 and 18. Along with these three we are going to perform and find out the molecular mass of the substance. So 18 plus oxygen 18, answer will be 36. Okay, Claire? So now how many peaks can be? 32, 33, 34, 35 and 36. Total 5 peaks will be there.
Okay.
Okay, so this is the end of this paper.